In the last video, I proved that stacking detection worked by logging stacked to the console window whenever one card was dropped onto another. That confirmed that the raycasting and the drop detection were functioning correctly, but there was no actually stacking system yet. In this update, I've replaced the debug log with a real stack function. Now when the card is dropped onto another card, the game either creates a new stack object or adds the card to an existing stack. The stack object is an invisible game object that becomes the parent of all of the cards in that group. When it controls their position using local offsets so they snap into a clean stacked formation. I also added a simple stack system, so a card is stacked, the physics script stops controlling its height. That prevents the physics system from fighting the stack layout system. Conceptually, the system works by separating responsibilities. Card behavior handles input and detection, the card stack behavior manages ownership and layout, and the card physics handles lift and rest height, but only when the card is not stacked. By giving each system a clear role, the stacking behavior becomes predictable and modular instead of chaotic. This is the system demonstrated. I have 5 card prefabs. I'm going to drag and drop one onto another. It creates a parent object. That parent object snaps the cards into place. I can create this with as many cards as I want to. As of right now, I do not have a card remove function or a stacking split or merging function, but that will be added in later videos. Thank you very much, and let's go into the scripts. Alright, in the last video, stacking detection worked, but it only logged stacked to the console. Nothing actually happened beyond that debug message. I'm going to be highlighting what's new in the script. I created a new boolean. Now each card keeps track of whether it belongs to a stack. This lets other systems like the physics script change their behavior based on that stack. Before, cards had no awareness of themselves being stacked. The next thing that changed is the check raycast for stack function. So when the mouse was released, it shoots out a ray and it checks to see what other cards are underneath. Beforehand, it was just a debug log saying stacked. Now I have created a custom function. So instead of printing out a message, the script now calls a function that actually builds or joins a stack. This is the biggest functional upgrade that has happened so far. This is going to be the new method that was created. So if the card I dropped onto already belongs to a stack, it adds the card to it. If it doesn't, it creates a new stack container and then adds both cards to it. It's getting the transform position of the base card. It's also checking to see whether the card is a son or daughter of another parent object. So it's checking to see the parent of that card, and then does that parent have the card stack behavior script attached to it. If it does, then it's going to add the card to the existing stack. Otherwise, it's going to create a new game object called card stack. This is an empty game object that will control all of the other cards. And then TJ card stack script, it's going to add the component TJ card stack behavior to this new game object. It's then going to transform the position of this empty game object to the base card. It's going to add the base card to the stack, and then it's going to add the card that I just let go to the stack as well. I'm now going to go through this TJ card stack behavior script, as well as go through what happened in the physics script. Alright, now I'm going to walk through the TJ card behavior script. The script is the stack container that owns multiple cards and controls how they snap into position. This, just like it was before, this is the name of the script. It's inheriting from mono behavior. This means the script is a Unity component that can be attached to any game object. This script does not go onto individual cards. It goes onto a separate game object called a card stack, and it manages the cards underneath it. This is an XYZ vector. The Y of 0.05 means that each card is going to be positioned slightly upward. The 0.25F means that it's going to be pulled slightly downward. This is going to make it look like an actual pile of cards rather than every card having in the exact same position. The serialized field. This is the stack's memory. It's a list of transform objects, meaning it stores references to the actual card objects. The private means that it can only be accessed within this script. The serialized field means that I can see it in the inspector inside of Unity. This is going to be important for debugging. The next is a line that exposes this list in a safe way. It lets other scripts read the stack contents without being able to add or remove cards directly. This is important because eventually I'm going to be passing this script into a crafting or the list into a crafting script. I don't want any other script being able to make changes as that could introduce bugs. The next is a function called add card. This function, I drop a card into another card. The my card behavior script eventually calls the add card to the correct stack. This is defensive programming. If the card does not exist or if there is a duplicate, then it will return getting kicked out of the function. It's then going to set the card as a child of the card object. So this is a major architectural line. It makes the card a child of the stack game object. It is important because the stack now owns the card in the hierarchy. We can now position the card using the local position, and if we move the stack object later, all the cards will move with it. This single line is what turns stacking into a real system rather than just a visual trick. The card stack behavior. So this is going to be setting the is stacked position, the is stacked boolean equal to true. And then afterwards it's going to add the card into the list, and then it's going to reposition the cards. Now here in the layout cards, this is the snap movement. Every time a card is added, we relay out the entire stack so everything lines up cleanly. Without this line, cards would be parented but remain wherever they were dropped. So public void layout cards, it is a public function. It does not return anything, and this is the name of the function. And then afterwards I'm going to be iterating through all of the items in the list. So this goes through each card by index. The index matters because the index determines the card's offset position. The transform T is equal to cards I, and then if T is equal to null continue, this grabs the card at index I. If the card is missing or destroyed, we skip so we don't crash. And then lastly, this is the most important line in the layout function because it uses local position. It positions the card relative to the stack object, and because it multiplies the offset by I, so a card 0 gets 0 as an offset and sits in the stack's origin. Card 1 gets 1 offset and it sits slightly above and forward from that. Card 2 gets 2 offsets, and so on and so forth. So overall, TJ card stack behavior is responsible for 3 things: keeping a list of which card belongs to the stack, parenting cards under the stack container, and laying them out using offsets so they snap neatly into place. This is what turns stacking from a debug log into an actual system. I'm now going to go through the changes to the TJ card physics. In the earlier version, the script's only job was simple. If I'm dragging, lift the card, otherwise put it at rest height. But once we added real stacking, the physics script started fighting with the stack layout system. So the big change is physics now backs off when the card is stacked. The private card behavior dash behavior. This already existed before, but now it matters even more because the card behavior contains 2 new states. Is it stacked and is it dragging? And then, if behavior is stacked and it is not being dragged, then it is being returned. If the card is stacked and the player is not currently dragging it, then physics does nothing and exits early. Once a card is stacked, the stack container is now controlling the card's position using the local position offset. If physics continues to run and it constantly forces the Y position into the rest height, then it overwrites the stack layout and the card will not stay snapped. So this return is basically saying if the stack owns the card right now, physics is not allowed to touch it. That prevents the two systems from fighting. Everything else remains the same. Now that I've got stacking working with real parenting and snapping, the next step is making stacks behave like a real system the player can manipulate. First, I want to add removing cards from a stack. Right now, once a card is stacked, it stays there, but next I want to be able to click and drag a card out of the stack. When that happens, the stack should update its internal list, relay out the remaining cards, and the remove card should become independent again. Second, I want to add splitting and merging stacks. So if I grab a card from the middle or top of the stack, it should split into two stacks. And if I drop one stack onto another, they should merge into a single stack with a clean order and a single parent stack object. This is going to make the whole system feel way more like a real card game instead of just a visual pile. Finally, I want to work on smooth movement and collision prevention. Right now snapping is instant, but I want to add tweening so cards slide into place instead of teleporting, and I want to make the table to feel physical, meaning if cards or stacks overlap, they'll relocate slightly so everything stays readable and doesn't clip through each other. Basically, I want stacks to intelligently spread out and settle like they have weight and space on the board. That's the plan for the next update, removing, splitting, merging, and making everything feel smooth and physical. Thank you very much again for watching. If you have any tips, recommendations, or suggestions, please let me know. Have a nice day.